Okay, put your pencils down, pick up your colored pens. Listen very carefully. We're going to go over today's warm-up. Today's warm-up is a review of things that you are already supposed to know. However, your warm-up must be correct by the time we're done, whether it's done by you or done by us as a group. So we can tell the difference because what we do as a group is done in colored pen. Your pencil is now on your desk. Okay? Equity bars are also in effect, so stay on your toes. So, number one. Number one, what is that equation rewritten in slope-intercept form? I've got student 21, student number 1, and student number 14. Student number 21, what did you get? Okay, student number 1, what did you get?
Y equals half x plus 3.
Okay, student number 14, what did you get?
Y equals 2x plus 3.
Y equals negative 1/2 x plus 3. Unfortunately, if you messed up that negative, then the whole thing is wrong, and number 3 will now be wrong, which means using your colored pen, you're going to have to correct it. Number 2, what is that equation rewritten in slope-intercept form? I've got student number 13, 8, and 18. Student number 13, what did you get?
Negative y equals negative x plus 3.
Student number 8, what did you get?
Y equals x minus 3.
Student number 18, what did you get?
Y equals x minus 3 or y equals
So it comes out to y equals x minus 3. Randy, you did the whole thing right, except you can't have negative y equals something. You have to change the whole thing. We're going to talk about that in a few minutes. Now graphing both equations on the same grid. So here is what you should have had. And here's how you can tell whether or not you have the correct graph. You have the correct graph if your two lines cross at this exact point. So now everyone look at where your two lines cross, and I want you to take your colored pen, and I want you to fill in or emphasize that point. What are the coordinates of that point? What are the coordinates of that point? Marlon? 4, 1. If you did it correctly, it is 4, 1. If you did it correctly, it is 4, 1. Unfortunately, if you messed up either numbers 1 or 2, then you have the incorrect graph and you have a different point or no point at all. So here's what you must do. Using your colored pen, you need to fix your graph right now if you have the incorrect graph. So take 30 seconds to do that now. I see some of my students did not draw the line going all the way through and all the way through. That is not optional, and we talked about that when we did the activity on the dry erase boards. That the line must go all the way through. Good. Does anyone have any questions on the graph? Now let's go back to number 2 for a moment. So, taking a look at number 2, we have x minus y equals 3. Could I have a volunteer, someone brave, tell us the first thing you did to rewrite it? Raquel? That was beautifully said. You subtract x from both sides, and I'm going to continue over here, and you end up with negative y equals negative x plus 3, which is exactly what Randy said. So Randy did a great job, except Randy missed a detail, and he's not the only one. And here's the detail. Slope-intercept form is not negative y. It's just y equals. So you have to figure out how do you get rid of the negative. So how do you accomplish that goal? Briante? Say it again. Divide negative what? Okay, I think you know what you're saying, but I'm concerned that some of my other students don't get what you're saying, so Danielle is going to piggyback off of you. Divide everything by negative 1. So if we divide by negative 1, divide by negative 1, and divide by negative 1, that will take care of that. But there's a shortcut, and that's what Briante is talking about. The shortcut is, Briante, flip the signs of everything. So the shortcut is flip it, flip it, flip it. As long as you flip everything, you can do that anytime you want. We can do it right now, right here. Flip it, flip it, flip it. That doesn't help us, so I wouldn't do it, but you're allowed to do that anytime you want, as long as you flip the sign of everything. Because it's exactly what Danielle said. In essence, you're dividing everything by negative 1. So then we end up with this. If you did this correctly, you end up with this. You graph both of them on the same grid. I told you, or we talked about, where they intersect. Does anyone have any questions on today's warm-up? Any concerns? Now look at the title of today's lesson. Guess what? You just did it. Wow. So we spent at least one day where we did rapid-fire graphing of equations on these dry erase boards. And we really tried to hammer home the idea of being able to graph things in the most efficient way. There was a reason. Because we now are entering into chapter 5 in which you're going to learn how to solve a system. A system is 2 or more equations all wrapped up together. So if you can't graph one equation, then how are you going to graph 2? You can't. So that's why we had to really make sure we had that skill down before we continued. Wow. Does anyone have any questions? Okay. Draw a line across your paper, but do not write anything. We are done with the warm-up. That's what this line indicates. You know that already. So I'm going to provide you an overview of what you're going to see in chapter 5. You do not need to copy these down. You need to read them to yourself. Read them quietly to yourself. It should take about 30 seconds to a minute. Good, I like the way I see most eyes up here reading. I assume if your eyes aren't up here that you finished reading. That's good. So let's sum up. We're going to be focusing on linear systems. A linear system is 2 or more equations, and I'm going to show you that formal definition in a moment. You're going to learn 3 different methods for solving them. You're going to learn the first today, this one, graphing. Next time I see you, you're going to learn how to use substitution, and after that, you're going to learn elimination. By the time we're halfway through the chapter, you're going to have 3 different methods for solving a system. And one of your jobs is going to be to, 1, figure out which method works the best for a particular situation, and 2, also decide for yourself which one makes the most sense to you. Because usually you'll end up using the one that makes most sense to you most frequently. Then, of course, the whole point of all of this is to be able to use these ideas in real-world situations. The last thing we're going to touch on is solving a system of linear inequalities, which is very challenging. Any questions about the overview of Chapter 5? Now you can pick up your pencil. So now let's talk more formally about what it is we're going to be exploring. Remember, these are notes. This is not something you copy word for word. A system is 2 or more equations, 2 or more linear equations. We're talking about lines, 2 or more lines. This year, we're pretty much only going to explore 2 equations at a time. When you get to Algebra 2, 2 years from now, you will start exploring systems that have 3 or 4 equations. I will, instead of saying system of linear equations, instead of saying this 4-word phrase, I will usually say linear system. Or I might just say system. Now, a solution to a system. A solution to a system is an ordered pair. You already know what an ordered pair is. But you've never really explored it quite like this. One of the biggest issues that I have observed over my time teaching algebra is that students get lost on what they're looking for. You get lost on what I'm asking you to do. So I want to start out by trying to emphasize what it is that we're going to be doing. And I'm going to continue referring back to it over the course of the lesson. But we're constantly now looking for an ordered pair. So let me take a quick little side trip, okay? If you didn't finish this, don't worry about it. I just want to take a quick little side trip. Now I have over here on my whiteboard, I've written an equation. Put up the number of fingers that will show me how many steps it's going to take for me to solve this equation. Everyone must put up a hand with the number of fingers. How many steps is it going to take? Okay, put your hands down. So I'm going to go ahead and do this quickly. Watch. If you're looking somewhere else or distracted by somebody else, refocus yourself. So I solved the equation. Give me a thumbs up if you think that I did it correctly. Okay, Janae, what did I do wrong? Oh, okay, I'm sorry, I went too quickly. Give me a thumbs up if you think I did it correctly. Some people think I did, some people don't. Okay, put your thumbs down. Of course I did it correctly. X is 6. X is 6. 6 is the solution to this equation. Sam, let me say that again. 6 is the solution to this equation. How many variables are there in this equation? How many variables are there? Selena? There's 1. It's an x, right? So there's 1 variable. I got 1 number. I got a value, 6. And I can prove that it's the correct answer by taking the 6 and putting it right there. 2 times 6 is 12, plus 6 is 18. I got the right answer, right? That's what you learned in chapters 1, 2, and 3. Now we're doing something related but different. We're not looking for one value anymore because now we're talking about systems of equations that have two variables, an x and a y. So a solution won't look like that anymore. A solution is going to look like that. So, this is hard work. I like my students to have an outline of steps so that when they get home later on or over the weekend and they don't remember what we did at all, they have something that they can fall back on so that you're not sitting and staring at a paper. So I've written out the steps for you. So here are the steps to solving a linear system using graphing. Step number 1, graph both equations on the same grid. Use any graphing method that you would like. That's what we spent all of chapter 4 developing. These different ways of graphing. Slope-intercept form is really easy. Finding intercepts, not as easy, but still pretty easy. Those are probably the two most common ones. So use any method that you think you can work with. Doesn't matter, as long as you graph both equations correctly. So that's not new. In fact, you just did it during today's warm-up. Step 2, find the coordinates of the point of intersection. That is a very fancy way of saying find where they cross. And we did that during the warm-up as well. Find where they cross. That is an ordered pair. So I know you guys are writing furiously, and that's good, but let me just quickly go back. Do you see this right here? That's an ordered pair. That is the point of intersection. This is a system. That is the solution to the system. So you've already done it once. So now back to this. Step 3, check to make sure you got the right ordered pair. Graphing is a human process, and humans make mistakes. When you're holding a ruler, if you hold the ruler a centimeter off a little bit, your line will be off a little bit. Now you're drawing two graphs on the same grid. What if you make a human error twice? The point where they cross might be off a little bit. So what we do is we check to make sure that we got it right. I showed you how to check for this. So today I'm going to teach you how to check an ordered pair. And you already know how to do it. If you are missing any of the notes that you need, leave a few lines of space before we go on to example 1. And I'm going to give you a heads up that we're going to start out with the more challenging work and move towards the easier. Well, when we get to the systems, we're going to move towards from the harder to the easier. But we're going to actually take care of step 3 first. We're going to learn how to do this, how to check. We're going to make sure we understand how to check, and then we're going to go ahead and learn how to do the whole process. Okay? So again, if you're missing any of this, skip a couple of lines and you'll fill it in later on. So here we go. Example 1, checking solutions. The instructions are going to say something like this. Tell whether the ordered pair is a solution of the given system. Let's make sure we're not distracted by part B. Let's just get rid of this for a few minutes. So here's what is happening. This is a system. There's two equations, and they have the same variables, x and y. That's a linear system. And I am proposing that this is the solution to it. I am proposing that if we drew these two graphs, that they would cross at 5, 2. So I could go ahead and draw the graphs and check where they crossed. But we're going to check a different way. We're going to check algebraically. And what it means is we take the numbers and we plug in. This is an x, that's a y, here's x, here's y, here's x, here's y. So we're going to check the first equation first. See if it works. If it works for the first one, then we're going to check the second one. If it works for the second one and the first one, then we say it's a solution. So, here we go. The first equation is 2/5 times x, but in this case x is 5, minus y, y is 2. And we're saying, does that equal 0? Some of it's mental math, some of it's actually doing work. So, 2/5 times 5 minus 2. What's 2/5 times 5? Caleb? It's 2. Very good. So we end up with 2 minus 2. Does 2 minus 2 equal 0?
Yes.
Yes, it does. So what we just proved is that that point is on that line. So it works for that. But for it to be the solution, it has to work for both equations. So now I'm going to change colors. You don't have to. You probably don't have the ability, but I'm going to change colors so you can see the difference. So now we're going to check this equation with the same point. So now 3 times 5 minus 2. Does that equal 13? Three times 5 is 15, minus 2 is 13. So it works. So it works in both of them. And so now we can say, yes, 5, 2 is the solution to the system. Let me go back to the warm-up for a moment so I can show you something. I want to make sure we're clear on it. If I put a point right here, that green dot is a solution to this equation. If I put an orange dot right here, that is a solution to this equation. In fact, I can put this orange dot anywhere along this line I want, and it's a solution to that equation. I can put this green dot anywhere I want on this line. That's a solution, that's a solution. All of these are solutions. But it's not until they meet right there that it becomes the solution to the system. That one point is the solution to the system of equations. This was a solution to one of the equations. That was a solution to one of the equations. If I bring them together, that's the solution to both. So now what we did here was we just proved that 5, 2 is where these two lines cross. Does anyone have any questions about that? So let's do it again and make sure we understand. Let's look at part B. We do the same thing. Let's check. So, take the first equation and plug in these values for x and y, for x and y. So, -2 plus 3 times 2, does that equal 4? Do some mental math. 3 times 2 is 6. Of course, you have to do that first. You always multiply before you add. 6 plus -2 is 4. So it works for that equation. But now we have to see if it's a solution to the other one. So now, this is a little confusing right here. -x, the opposite of x. So here's how you write that. The opposite of x plus y, does that equal 2? Well, what's the opposite of -2? Cameron? 2. So this is really 2 plus 2. Does that equal 2? No. It does not work for the second equation. It does not work for that one. So what that means is this point is on this line, but it is not on this one. And so no, it is not the solution to the system. Does anyone have any questions about what we did? So all we've done so far is learn how to do step number 3. Any questions? Okay, checkpoint number 1. You've got 2 on your own, and it is your job to prove to me that you have absorbed what we just discussed, and it makes sense to you. 2 questions, you got 3 minutes, 1.5 minutes per question. Don't go slowly, don't rush, but make sure you work at a good pace. pencils down, pick up your colored pens, and we're going to do this by survey. So everyone get ready. We're on part A. Give me a thumbs up if you think that 1, 3 is the solution to the system. Okay, put your thumbs down. Yes, it is. Part B. Give me a thumbs up if you think part B is a solution to the system. No, it is not. So as far as I can tell, everyone got both of those questions right, but now we need to brave people. For part B, which equation does it not work for? Which equation does it not work for? Oh, we got a whole bunch of people. Kyle and then Kiara. Kyle, which one? Kiara, which one did you think? Yeah, it doesn't work in the second equation. Very good, both of you. Does anyone have any comments or questions on what we've done? So now we're going to put this together with skills that we already know and already have and do solving a system by graphing. I already gave you a heads up that we're going to start out with a more challenging one and then we're going to move to a slightly easier one. So, example 2. Solve the system graphically, then check the solution algebraically. So the system is 5x plus 4y equals negative 12 and 3x minus 4y equals negative 20. So, step 1 that you already wrote down. Step 1, graph both on the same grid. So we have both equations written down. Of course, you have them both written down. Go ahead and make yourself a nice, decent-sized grid, about 10 squares in each direction. Don't be afraid to use your graph paper. You need to use large parts of the graph paper. But this is the first time we're doing this formally, so I'm going to go a little bit slower, and I'm going to do a couple things to help us move along in a reasonable way. So personally, I think, based on my experience, that it's a little overwhelming to look at all of this. So what I'd like to do right off the bat is make our lives a little bit easier to start with. And so let's get rid of this equation for a minute or two. And let's just focus on the first one. 5x plus 4y equals negative 12. We have to graph it. 5x plus 4y equals negative 12. How can we graph it? Briante, Cameron, and then Caesar. What do you think? Okay, so sum that process up. That's called doing what? Because you're absolutely right. Okay. Does anyone know what she was describing? Cameron? Intercepts. Okay, finding the intercepts. Okay. Cameron, you had been waiting after her. What were you going to suggest?
Put it in slope intercept form.
Put it in slope intercept form. Okay, Caesar, what do you
I
suggest?
was going to say intercept.
Intercepts. Okay, so Briante, you're going to use intercepts. Caesar, you're going to use intercepts. You're going to put it in slope intercept form. Okay, so you can go ahead and get started. Everyone else, we're going to use intercepts. I personally think intercepts, when it's in standard form, usually works out a little bit easier. Sometimes not, but sometimes it works out. Most of the time it works out easier. So what Briante said was to find the x-intercept, we make the y a 0, and you already know that basically this disappears, and we end up with 5x equals negative 12, and now solve that equation. We get x equals negative 12 fifths. Well, that's an ugly number, but don't worry about that. We're going to be okay. So we just found the x-intercept. Now we need the y-intercept. So Briante, how do I find the y-intercept? Make the x a 0. So now we're going to do it again. Make the x a 0, but we'll be left with 4y equals negative 12. Solve that, and that one comes out nice and friendly. We get y equals negative 3. And so using intercepts, we were able to quickly find 2 points, that point and that point. Now we need to put them on the grid and draw a line through them. Negative 12 fifths, I know, is a little uncomfortable. Could someone say that number in a more comfortable way? What is another way to say negative 12 fifths? It's a little more human. Caesar?
Negative 2.5.
Close. It's not negative 2.5. Danae? It's negative 2.4 or negative 2 2/5. So that makes a lot more sense when you're talking about graphing, because I don't know where negative 12 fifths is, but I know where negative 2 is, and I know where negative 3 is, so I'm going to be about halfway between, and that was great. So now let's go ahead and plot the x-intercept. Negative 2.4 is going to be about right there. It's a little bit less than halfway. Mine looks like it's about halfway, but that's close enough. And then the y-intercept is at negative 3, so that's easy. Just put it at negative 3, put a nice clear dot, and now you pick up your ruler, and you draw a line. Make sure your line is as accurate as possible, and make sure that you draw your line all the way through the grid. All the way through. So we graphed. We already knew how to do that. Great job. So now we're elevating. We're going beyond what we know. Now we're doing a system, and that's where this comes into play. Now we have another equation. 3x minus 4y equals negative 20. Cameron is still going to use the same method, which was what, Cameron?
Slope-intercept form.
So he's going to convert that to slope-intercept form. Some other people might be doing that. The rest of us are using intercepts. I'm going to change colors so you can see it a little more clearly. And so now we need to do 3x minus 4y equals negative 20, and we need to find the intercepts. So first we make the y a 0. This whole thing will disappear. We end up with 3x equals negative 20, and we end up with x equals negative 20 thirds. Again, a little bit uncomfortable, but really not that big a deal. Yeah? You're going to say what that could be? Go ahead, what is it? Okay, but it's negative, so... But yeah, you're absolutely right. So negative 6 2/3. Absolutely. Now we need the y-intercept. So we make the x to a 0. We are left with negative 4y equals negative 20. And that one comes out a little bit more friendly. We get y equals 5. And so again, we got the x-intercept. We got the y-intercept. Plot them both and draw a line. So he said negative 6 2/3. So that's negative 1, 2, 3, 4, 5, 6 2/3 will be about right there. And 5. 1, 2, 3, 4, 5. Put a dot. And now draw a line through them. Make your line as accurate as possible. So believe it or not, that was all step 1. So we just graphed the system. We used the method of intercepts to do the graphs. But we're looking for something. Could someone remind us, what is it that we're actually looking for? What are we looking for, Jamel? You said that beautifully. The point where they intersect. And so now we need to figure out what point are they actually intersecting at. Now my graphs are actually a little bit off. They're not perfect. And partially because of these numbers being tough to graph, it came out a little imperfect. But where do you think it's crossing? Where do you think it's crossing, Raquel? Essence, do you agree with that? You also thought -4, 2? That's what your graph looks like? So we're going to say that we think that this is going to cross at -4, 2. We think. Before we circle our answer and pat ourselves on the back, we're going to check. And we're going to use a lot of mental math. Make sure you do good mental math because we don't want to mess it up. So what we're going to do is we're going to check, and I'm going to do it right here. I'm going to take these coordinates and I'm going to plug it into both of these, and I'm going to mentally do the math to see if it works. So 5, I'm getting this from the first equation, 5 times -4 plus 4 times 2, does that equal -12? And then I'm going to check the second one, 3 times -4 plus 2 times, nope, that's not right. -4 times 2, does that equal -20? So let's do the mental math. 5 times -4 is -20. 4 times 8 is, 4 times 2 is 8, so that one works. That's -12. That's an 8, but I'm subtracting it. -12 minus 8 is -20. That one works. Now we know we got the right answer. And so, this is the solution. Believe it or not, on the answer sheet, you're not going to see any of this, except for this right here. For your homework tonight, the answer sheet is just going to be a bunch of answers like that. So it'll be very obvious to me who did their work and who didn't, because to get this, you have to do all of this, you have to draw the lines, you have to check, and then you can say the answer. If you just write down an answer, of course, you didn't do a thing. Okay? Does anyone have any questions on the process that we went through? Graphed, found the point, checked. Any questions? All right, so let's do it again. Part B. You don't have to write example B and all of that. You just need to write part B because it's the same exact instructions. But now we have a new system. Set up a new grid. And now let's do a little bit of pre-work. A little pre-analysis. Do you think this one's going to be easier than the first one, the one we just did, or is this going to be harder? What do you think? Kayla, what do you think? You think easier. Danielle, what do you think? Kyle, what do you think? I'm sorry?
I think it's going to be hard.
Harder? Okay. Anybody else? Selena, what do you think? You think it's going to be easier, DeAndre?
This is so easy.
It's so easy, okay. So let's go back. Kayla, why?
Because in the first one, it only gives you slope and y-intercept.
What form is that called?
Slope intercept.
Okay. Kyle, why did you think this one was going to be harder? It's an opinion question, so I'm just asking.
Well, because like it wasn't the same.
Okay, so it wasn't in the same form as the first one. You're absolutely right. What form is this one in? Okay, so you recognize something very important, but Kayla really touched on something from that, which is that slope-intercept form tends to be really easy. See, in this question, to graph it, we had to do all this work just to draw the graph. But when it's in slope-intercept form, the work is already done for you. Let's look at the first equation, y equals negative 2x minus 1. What's my starting point? This is where all the hands frantically wave in the air going, oh, I know. Here, it's negative 1. So all I have to do is put a point at negative 1 and then use my GPS, negative 2 over 1, to get my next point. Down 2 over 1, put a point, and now I can draw my line through it. Make sure you draw an incredibly accurate line. And now in the second equation, what's my starting point? Andrew? 5. My starting point is 5. So I go 1, 2, 3, 4, 5. Put the point. What's my GPS in the second one? What's my GPS, Selena? You said that beautifully. Up 1 over 1. Put a dot. Up 1 over 1 if you want to put another dot. Draw a line through it. Jamel, because you did such a good job the first time, could you remind us, what is it that we're actually looking for after all this work? Where they intersect. So we're trying to identify what is that point right there. Jamel, do you think you know the coordinates of it? Negative 2 comma 3 is our proposal. We have to check. So let's check the proposal. I got some space over here, so I'll do it right here. So now use the first equation. 3, does that equal negative 2 times negative 2 minus 1? And now the second equation, 3, does that equal negative 2 plus 5? So let's see. Negative 2 times negative 2 is positive 4. Positive 4 minus 1 is 3, so this one works. Negative 2 plus 5 is 3, so that one works. So we got the right answer. The solution is negative 2 comma 3. That is what we were looking for.
Is it possible for the answer to be a no, or just you have to keep writing the answer to make it easy?
Okay, so you just brought up a really good point, okay? What if I mess up and I do this?
Oh my god.
What if I accidentally draw my line right there and I say, I think that the answer is negative 1, 2, 3, 1, 2, 3, 4, 5. Negative 3 comma 5. Because I didn't realize that I made a mistake, right? So I'm working hard, I'm at home, I worked hard all day, I'm doing the work, I draw the line, and now test it out. So now you check and you go, okay, wait a minute. Negative 2 times negative 3 is 6. 6 minus 1 is 5, so that one works, but now let's test it out here. Negative 3 plus 5 is 2. Oh, that doesn't work. So it didn't work. Now I have to unfortunately go back and try and figure out where did I mess up, because I messed up one of the lines. Okay, So let me back up and make sure we're not confused. We did do it correctly. That was the correct one. Okay? So Sam, thank you for bringing that up. Very important. So you do have to keep checking until you get the right one. Any comments, questions on what we've done here? So you've actually done it 3 times already. You did it once during the warm-up. You practiced checking solutions. You did a difficult one because the graphing was more challenging. You did a slightly easier one because the graphing was a little bit easier. Now do one on your own. Checkpoint number 2. Since the process does take some time, you got 4 minutes on the clock. Go. Okay, Put your pencils down, pick up your colored pen. Give me a thumbs up if you already know you have the right answer. Good, put your thumbs down. Equity bars are in effect, so let's see what answers we got. I got student number 17, 13, 14, and 5. Student number 17, what'd you get?
3, comma, negative 2.
Okay, student number 13, what'd you get?
0,
Okay, student number 14, what did you get?
3, -2.
Okay, student number 5, what did you get?
3, -2.
Okay, well, one person disagreed. The correct answer is, that's supposed to be a negative 2, so I apologize for that. It is 3, comma, negative 2. That is supposed to be a negative 2. And here is the graph that you should have constructed. And you can clearly see that they cross at 3, comma, negative 2 right here. Now, Randy, I am going to use you to prove a point. Okay, I'm going to use Randy to prove a point. Randy didn't do anything wrong. I'm just going to use him to prove a point. Randy, what was your proposed answer? 0, comma 1. Okay, so Randy proposed 0, comma 1. 0, comma 1 is right here. Okay, so now visually you can see that that's not the solution. But Randy made a mistake on one of his graphs, so that's okay. But here's the mistake, the true mistake that Randy made. Randy clearly didn't check. Remember I asked you if you already knew if you had the right answer? You knew because you checked. If we check Randy's answer, we will see that it doesn't work. We put a 1 here equals 1/3 times 0 minus 3. We get 0 minus 3. That doesn't work. We already know it doesn't work. You already knew that this was the wrong answer. So you have to check your work. It's not optional. Anyone have any questions or comments on what we've done here today? Now, the whole point of all of this is to apply it to real-world scenarios. So, don't do anything, just listen. We have an important question that we need to do. I am just about out of time, and so I cannot start it now. It will be a waste. It will be meaningless. So I am going to find a time early next week. I'm going to give you your homework assignment. You will be fine on the homework assignment. You will be able to do all of it. So everyone draw a line across their paper. Your homework is page 272, numbers 1 and 2, page 273, numbers 1 through 5, and page 274, numbers 1 through 4. That's 11 questions, and I would like you to tear out the pages from your book and do the graphs on the pages, but you need to do the work. You need to show me the work. You need to show me if it's a graph that was in standard form, if the equations were in standard form, and you need to do intercepts, I want to see the work. You need to check. I want to see the checks. Now, you have your semester exam on Tuesday. I gave you a study guide already, so that's what you should be working on to get yourself ready for the semester exam.